And we're going to do the same thing here. Now, as I was looking at some of the book and looking at the homework assignment, they don't require you to use radians to solve for these here. You can use degrees. But all that's going to do is change the equation slightly, because instead of using 2 pi, we're going to use what? 360. Because 2 pi and 360 are the exact same. So we can just use the same formula. Z of n is equal to nth root of r times cosine of theta plus 360 k over n plus I sine of theta plus 360 k over n. So it's the exact same formula, but instead of 2 pi, we're using 360. Now, we saw an example of this before where we were given the equation. We found r and n and k. And we're going to do a similar thing here, but instead of it already being in kind of the form we want or in complex form, they gave it an equation form. X to the 5th plus 243 equals 0. So really we're wanting to find the 5 roots, because 5th power, that means we're going to have 5 roots. So our n value for this is 5. Our k starts at 0 and goes to what? 4, because we're going to n minus 1. Now we still need to find r and theta. Now to find r, we can really set this up as x to the 5th equals negative 243. I'm going to subtract everything over to the other side. So we're moving everything to one side. And we can solve it from here, because really 243 plus 0i is our a and b. Now at this point here, to find r, well, r is equal to the square root because we would square 243, which would give us a big number, yes? Square rooting it would give us, it would be positive 243, because negative 243 squared would give us a big positive number, and when we square root it, we would get back to 243, but it would be positive, not negative. It'd be positive. So r is 243. Okay. Theta is equal to tangent inverse of over a. That's tangent inverse of what? 0. Now, x, or our a value, is positive or negative? It is. So if it was positive, we would be at the positive x-axis between quadrants 1 and 4. But since it's negative, we're actually over between 2 and 3. So we have to add what to it? 360 or 180. Pi or 180. Because on a normal quadrant, 0 degrees is over here. But our negative value is over here. So we have to add pi or 180 to it. Questions on this here? So we'll do this one in degrees, so we can see it both ways. So here, our theta is 180. All right, let's get this started. Z of 0 is equal to Well, the fifth root of 243. Well, before we can go further than that, what is the fifth root of 243? It'd be really nice if that's 3. Okay, well, we know that's 3. We don't need to rewrite that. We can just say it's 3. So go on and simplify it. Now we have cosine of 180 plus 360 times 0 all over 5, because that's the number of roots we're taking, plus I sine of 180 plus 360 divided by times 0 over 5. Well, 360 times 0 is gone. So we're really looking at 180 divided by 5. Cosine of 36. So if we look at z naught, well, I would just go on and type it in as 3 times cosine of 36 and 3 times sine of 36. So just do 3 cosine of 36. And we get or just, that's it. So 3 cosine of 36 degrees, and then do 3 sine of 36 degrees. Yeah, we can just come down here to 2.427. 2.427. Huh? Positive. That makes more sense. 2.427 plus, and then if we do it with sine, we get what? 3 sine of 36. And we get this here. Now, the reason I said that makes a little more sense is because if we think about the fact that our angle that we're looking at is 36 degrees, yes? Which quadrant is 36 degrees in? Number 1, yes? So x and y, sine and cosine, should both be positive. We shouldn't have a negative. All right, we finished the first one. I wrote it down on the sideboard, and I'll list them back up here later. Now, we're going to do this again, but one main thing is going to change. What is that? So our z is now going to be z to the 1. So inside, we're going to have 180 plus 360 times 1 over. Now, we could go through and solve it individually. And what I mean by is do 360, or 180 plus 360 times 1, which is just 180 plus 360, which would give us 540. Or we can plug 180 plus 360 divided by 5 into the calculator. And get 108. Now again, we could do sine and cosine of 108 and write that down and then multiply it by 3. Or we can just do 3 times cosine of 108 degrees, which would give us, for cosine, yes.
It's 0.927.
And then sine would be? And that's Z1. We agree, Tori?
Sure.
Yeah. So if we did in degrees, 3 cosine of 108, we get that. 3 sine of
108.
Yep. And we get this here, and that's it. So that takes care of Z naught and Z1. Well, for Z2, well, pretty much everything in here stays the same, but now we're multiplying 360 by 2. And as I said already, we could do 180 plus 720 because 360 times 2 is 720, and add it to 180, but that's going to give us 900. And if we divide it by 5, we'll get 180.
No, last time was 108. The
No.
8 is slowly moving.
Cosine of 108 is
0 and one of them's 1, right?
Sine is 0. Cosine is -1. Yes? Yes. Yeah, because we times it by 3. So Z2 plus 0i, but it's still the same as. Three. I'm just going to erase all that. Because this time, I have 180 plus 360 times 3 over 5.
It'll be. What you want to say? Another one. 52. It's got the other side numbers.
So if we do 180 plus 360 times 3 divided by 5, we should get 252. Now we can do 3 cosine of 252 and 3 sine of 252. If we do 3 cosine of 252, so negative what? 27
What's my answer?
minus 2.85.
No, it's on the. No, it's the second one's negative. This,
Yes.
Z1 is in the first one.
Right.
Okay.
And this is what we should get. We should get for this last one 2.42 minus 1.763. Now, that's what we should get. And I erased way too much, but that's okay. Because this time we'll have cosine of 180 plus 360 times 4 divided by 5 plus I sine of 180 plus 360 times 4 all over 5. Now if we do 180 plus 360 times 4, and if we multiply this out, we do get 2.427 minus 1.763i. Because all of these terms with I are going to have a pair. They're going to have a conjugate. Because if you remember back to the complex conjugates, if a plus bi is a factor, a minus bi must also be a factor. They always go in pairs. Negative 3 doesn't have a conjugate pair because its conjugate pair would be negative 3. Because we have plus 0i. Questions on this here? Have we found all the roots? Found all 5. And all 5 of our roots, that's all this here, are going to be 2.427 plus 1.763i, negative 0.927 plus 2.853i, negative 3, negative 0.927 minus 2.853. And last but not least, we have 2.427 minus 1.763. And that is all of our solutions. Questions on this here? All right. Okay, and the assignment is this right here. So I went on and I actually am including this in the recording. Oh yeah, no.